Hey, good morning, everyone. Thank you for getting up and coming to my session so early this morning. That's made my day. So, I'm Mickey Gousset. There's a slide at the end of my deck that has more information about me if you really care. But essentially, I'm a principal consultant team lead at Infront Consulting Group, and I'm also a Microsoft what are we Visual Studio and Development Technology MVP, and have been for about the past 13 years. So today, we're going to talk about Azure Machine Learning, which is something that I have gotten really psyched about over the past couple of months, and so I hope that you will find interesting. But more importantly, I am from Tupelo, Mississippi in the United States. And I am a small 25,000 person town in northeast Mississippi, but we have over 100,000 people a year that come to Tupelo, over half of which come from Europe to see my small town. Does anybody in here know why Tupelo, Mississippi is world famous? What? It is the birthplace of Elvis Presley. That is correct. So Elvis was born in a small two-room house, not two-bedroom, but two-room house in Tupelo, Mississippi. So people come to Tupelo to see the house he was born in, see where he bought his first guitar at the hardware store. And for you, sir, I have an official Elvis birthplace trucker cap from the Elvis birthplace in Tupelo, Mississippi. So thank you. So now that we've gotten the fun out of the way, Elvis, let's have some more fun. So, as you've probably experienced, we have 45 minutes to cover a whole lot of information. So therefore, I'm going to assume that most of you know what machine learning is, but we're going to briefly cover it, and then we're just pretty much going to jump into demo. And we're going to build a model from scratch. We're going to build our workspace. We're going to build a model. I'm going to try not to talk too fast. And we're going to deploy that model up as a web service. We're going to build a web app that can make use of that web service. We're going to show different ways to test that model. Then we're going to train the model some more, make some changes to it. And then ultimately, we're even going to look at how we can use some Python to help us do some data analysis as well. So it's not all necessarily just drag and drop. So if you've been doing machine learning in the past and you've been doing it with Python or R, you're able to take those scripts that you've already been using and be able to integrate them into the Azure Machine Learning aspect of it. But most importantly, in our demo, as part of our demo, we're going to use one of the classic machine learning demos, which is being able to predict if someone would have survived the Titanic. So it should be fun. But when we talk about machine learning, we're talking about a computer that's going to learn from data that we give it to do some kind of predictive analytics. And there's a whole machine learning is its own whole class of stuff. There's all kind of algorithms and things. And as programmers, we want to write our own algorithms, but there's no need to reinvent the wheel when people have done a whole good job for us. There's two types of machine learning you need to be aware of: supervised and unsupervised. Supervised machine learning is you give your experiment a whole bunch of data, and you tell it the result that you're kind of wanting it to predict, and it will then try to predict that result. That's what we're going to be doing today. We're going to be doing regression machine learning, trying to predict if someone would survive the Titanic. There's also unsupervised learning, which is where we say, here's a bunch of data, what can you tell me about it? So that's a little more complicated. So we're going to stick with just the supervised learning. The reason we're going to be talking about Azure Machine Learning is because it is a whole cloud service now around doing machine learning. It kind of opens up machine learning to the masses in some respects, because you don't have to worry about spinning up the machines that you need. It's got a nice drag and drop interface with a lot of the major algorithms in place there. You can make use of R, you can make use of Python. And as you'll see, we're going to do this from scratch, and we'll be able to have a workspace and start working within just a few minutes. The general machine learning process that you need to be aware of is that you're going to have some data. And the first step with any machine learning is you have to understand the data. And you're going to spend the longest part of your time understanding the data and cleaning the data. So we've got to prepare that data to make sure it will work the best it can in our algorithm. Then we need to pick the particular algorithm we want to use, and we put it in our model, and we see what the results are. Maybe it works great, maybe it doesn't. Maybe we pick a different algorithm, and we keep doing that until we find one that we think we like, And then once we like it, we could deploy it and start using it with different applications. And we can always continue to train that model. We can always change that model. And you'll see that this morning. But as I mentioned, so we're about to just go demo from here on out. So we're going to talk about, would you have survived the Titanic? But in reality, I'd like to introduce you to someone. This is Brian Randall. He's my fellow speaker from my bot talk yesterday. He's also my best friend forever. So I'm really concerned if Brian would have survived the Titanic. So that's what we're really concerned about today, is figuring out, would Brian have survived the Titanic? So with that, I'm going to start off in the Azure portal, and I'm actually going to come out here and I'm going to create myself a new machine learning workspace. Now this, you don't have to necessarily do it this way. You can go to the machine learning site and create a free workspace that you can use, but the free workspace obviously has some limitations on how much you can run. So we're going to create this, and we're going to call this my workspace MG TechDays 17, October 13th, just to give it a good space. And we're going to create a resource group. And a resource group is basically a container that's going to hold everything that we care about. Let's not put this in South Central, but instead put this in West Europe. So let me get this started, and then I'll come back and explain exactly what I'm doing here, so it'll have a chance to spin up. So what we're doing here is creating our initial machine learning studio workspace. So that'll take just a moment to spin up. And what we've done is we have to give our workspace a name, obviously. A resource group in Azure, think of it as a container of related stuff. So I can put everything related to, say, my machine learning in this resource group, and then if I decide I don't need it anymore, I delete the resource group, deletes everything else. Obviously, I pick a location closer to you, works better. Storage account for being able to store certain information. The pricing tier, we have multiple pricing tiers. There's a free tier that gives you some access. I chose the standard tier just to make sure I can do everything I want to do in my demo. And then of course we're going to be building out a web service from this, so therefore we need to have a web service plan to handle that. And we can see that my workspace is created. So let's go to resource. And so this is what we get inside of Azure. And what I really care about, though, is my machine learning studio. This is where we do all of our work, right? So let's go to our machine learning studio here. And you can see I've been doing some testing. So I'll switch over to West Europe. And there's the, oh, hey, look, I created two. Let's hope it's this one. It is. So here's the I'm in the workspace that I just created. So this is Machine Learning Studio. This is where you do all of the heavy lifting. You can aggregate your different experiments and notebooks and such into projects. You have your experiments, which are the actual, building out the model that we want to build. We have the web services that we may have built from these models. We have notebooks. These are Jupyter notebooks. Anyone in here used Jupyter notebooks before? So Jupyter notebooks, they're really cool. I think they're really cool because they're a way to basically be able to take, like, say, Python or some R code and be able to run pieces of it at a time and see the results. And then it's kind of an interactive website that lets you do that. We can see our data sets. We can also see our trained models. But you know what? We need to get started. So we need, because we're running out of time. So we need to create an experiment. So if I go down here and click the new button, the cool thing about the Azure Studio is that they have a bunch of experiments pre-created for you. So if you really want to learn how to do something, or you really want to see some fancy experiments, then you can come play with these pre-created ones. But we're going to start with a blank experiment. And we probably need to give this a better title. So, does Brian survive the Titanic? So let's just take a quick poll real quick. How many people think Brian's going to survive the Titanic? Yes, Brian only travels first class. How many people think he will not survive the Titanic? Okay. So it's about half and half, Brian. Brian has a session at 11:30, 11:45, if you'd also like to go see his session. if he lives. So first thing we're going to do is add a new data set. So what I've done is I've gone to a site called Kaggle.com, which has a lot of different machine learning data sets that you can use for a lot of different things. And they have a set of Titanic data. Now, while that's loading up, if we look at this data, this is what the data looks like that we've gathered from the Titanic. And what this data means is, this is passenger ID. This is just a primary key for this table, so to speak. We've got survived. 0 means that they died. 1 means that they survived. Brian wants a 1. This is the class. So 1, 2, or 3 would be, they were calling it high, middle, or low. So basically, it was social economic class. It's also class where you were in the boat. They've got their name, whether they're male or female, their age. This is sibling or spouses. So did they have any siblings with them, or did they have any spouses with them on the boat? And this is parent-child. Did they have any parents with them, or did they have any children with them on the boat? And then we have their ticket ID, their fare, what cabin they were in, and the city they embarked from. So this is all data that they've gathered from the Titanic. Some of this is relevant, some of this is not. Now, my data set has been loaded, and I can see it under my data sets, so I can just drag it over here. I just drag the data set onto the screen. Now, you'll notice that the different activities on the left have endpoints on them. And I can right-click on an endpoint, and in this case, I can actually visualize the endpoint. And it will actually show me, in this case, I've got 891 rows. It shows me each of the columns, the values. We've got pretty little graphs here that show us, say, statistical information about that column. Columns are also referred to as features. You'll also notice in looking through this data that I've got some columns that are empty. So my data is not clean. It's not ready for me to use yet. I'm going to have to do some manipulation to it to get it to the point where I can use the data the way I want to use it. But being able to visualize the data at each step in your process is a really nice feature. So we've got our data. Before we can build our model, we've got to clean up our data. So how do we clean up our data? Well, first off, we only select the values that we need. So in this case, we know that women and children were evacuated first. So age and sex are going to be important characteristics. So what I can do is come over here and find the select columns from my data set. And I need to link this up. So I can simply drag one endpoint to another. And when I select an endpoint, you'll notice how it turned green. So I know where I'm supposed to go. And also, I can tell that, oh, I've got to do some manipulation on this particular activity. So in this case, I need to select the columns that I want to use. So I'm going to use survived, P-class, sex, age, sibling, and parent. So I only care about those 6 columns. Now, I highly recommend, I'm not going to necessarily do it in my demo today, but I highly recommend as a best practice that you constantly save and constantly run to see where things stand with your project. The reason I'm not necessarily going to do it constantly today is because, obviously, every time you run it, it takes a little time. So you can see it's going to run, and we'll see check marks appear as it runs. Right now it's queuing up. There we go. And then once it finishes running, everything ran successfully. I can right-click, and I can visualize the results. And in this case, we're now only selecting the 6 columns we care about. So we're doing some data manipulation. Now, one of the other things we need to look at is, say, for the survived column, there's only discrete values that the survived column can be, so which are 0 and 1. So we really don't, need to worry about individual values in between. So in reality, we need to make this what's called a category. A categorical column has, will you hate me if I hold questions to the very end? Okay, thank you. A categorical column has just specific discrete values. So we want to set certain things like our survived column and our P-class column as categorical. We also want to clean up this data from the standpoint of removing some of these rows so that we don't have to deal with that anymore, or so that those won't affect our values that we're dealing with. So our first step is going to be we're going to edit some of the metadata. So editing the metadata, again, we just link this up. And we specify the columns that we want to edit, and we can use this to do a variety of things, such as changing column names. In this case, what we want to do is select these 4 columns, and I want to make them categorical. Next step, I want to get rid of those empty rows. Hey, look, I have a great activity called clean missing functions. I can drag that in there, and I can say, what do I want to do if I find an empty value in a feature? Well, in this case, I want to just remove the entire row. Beautiful. So I can save this and run this again, and just to prove to me that this is working at this point. Because once we've gotten to this point, now we've cleaned our data, and now we can actually start building out our model. And I'll show you that we can clean our data, because if you'll remember, we initially had 891 rows, and now if I look at the clean data, and I do a visualization, we're down to 714. So we've cleaned up our data, we're ready to go, we're ready to build our model. Well, when we build these models, we want to both train them and test them. And we could pass in 2 different data sets, one for training and one for testing. In this case, I'm just going to use my one data set, and what I'm going to do is split it into 2. So in this case, I'm going to do an 80% for training and 20% of it for testing, and I'm going to have it randomly choose the values that it's going to use. So with that in place, we've got the split data in place, we've done all those things. Now we need to build the model. So how do we know what model we want to use? Because we've got like 25 or 30 models here that Microsoft provides that we can use. So how do we know which one to use? Well, they have a pretty little graphic that you can download, which actually helps you choose which model to use. In this case, we're doing predictions. We're trying to predict 2 values, did Brian die or not? And so therefore, we're going to do a 2-class classification. And I'm going to start off with the 2-class decision forest because it's accurate and it trains pretty fast. Some of these you can see require a larger footprint, are slower to train, but we're going to go with accuracy and fast training. So if we flip back over, and I go to, I need to add a train model activity, which does the actual training. And I need to specify which activity I want, or which model I want. So we want the 2 model, no, sorry, typed the wrong one. What did we say we want with the 2-class? We want the 2-class decision forest, I think is what we decided we wanted. Now, 2-class decision forest hooks into the training model. We pass in the data we want to use to train, and we tell it what value or values we want it to try to predict. And in this case, we want it to try to predict whether Brian survived or not. Now, once we train the model, then we need to score the model. Once it's trained, we need to know, okay, how well did it do? So that's what we use the test data for. So we grab a score model. We link in the score model. We add in the test data. And then finally, what we want to do is evaluate this model. Now, what evaluate does is calculate some values for us to tell us how good our model worked. And we can also use it to compare multiple different models. So we can save this and we can run this. And what this will do is hopefully, if we've hooked everything up correctly, it's going to give us a model that now, if we think it's working well enough, we can push off onto a web service. Because Brian's not going to come into my workspace and use this. He's going to require some other kind of interface. That's just how Brian is. So let's see where we are. So you can zoom in and out, see where things are. Right now, we're finished training the model. We're working on scoring the model and then doing the evaluation. And what we'll be able to do is we'll be able to look at score model and visualize its results. And from that results, we can see that here's our initial inputs. There's a scored label, which is its prediction of did Brian survive or not, and then the probability of Brian surviving. If his probability is 50% or greater, he survives. If not, he doesn't. So in this case, you can see here, this person only had a 32% chance, so therefore it marked them as not surviving. And some of these are accurate, but some of them aren't. Here, this person did not survive, but it scored them as having a 62% chance of surviving. So your model's not perfect. So how do we know whether the model is any good at all? Well, that's where we look at some values. So if we look at evaluate model and go to visualize, this is what's called, let me get it right, the receiver operator characteristic graph, the ROC graph. So what you care about on this graph is the area under the curve. You can't see it on this screen, but if you imagine a diagonal line going straight up, the closer you are to that diagonal line going straight up, the more your algorithm is guessing at a value. The farther the line is up to the left, the more it knows what it's doing. So ideally, you want a line that goes up and over in an ideal world. But what you care about by looking at this is what's called the area under the curve, AUC. And the area under the curve is, 84%. Good, bad? I'll take it. I feel confident for Brian. This is called the confusion matrix. These four numbers right here are called the confusion matrix. So what you're looking there is true positive. So true positive is we correctly predicted someone would survive. So remember, we're passing in test data, so we know the actual answer, so we can tell this. True negative is we correctly predicted someone died. So we correctly predicted things. False negative, we predicted that someone would die when they actually lived. False positive, we predicted someone would live when they died. Ideally, true positive and true negative, you want big numbers. And false positive and false negative, you want small numbers. There's some other values here that we care about, such as accuracy. Accuracy is the number of correct predictions divided by the number of total predictions. That accuracy value is okay. Accuracy can be misleading depending on your data. If your data is spread over a broad range, it's a pretty good indicator. If you have wild data points, it's not necessarily a good indicator. You've got precision, which is the number of correct positive predictions. You've got recall, which is the number of correct predicted positive events. In this case, did people survive? But the number that you really care about out of all these is what's called this F1 score. That's also called the harmonic mean of precision, and essentially that is a single number that you can use to compare multiple models together to see which model is better. Some things to think about with precision versus recall are such as, let's talk about breast cancer. One of the things that people use machine learning for is to diagnose if someone may have breast cancer or not. If your precision is high, that means that we're diagnosing it successfully. So we're diagnosing it correctly, everything is great. If your precision is low, that means that patients that don't have breast cancer, we're potentially diagnosing with breast cancer. Now, that means that that's good in some respects because they don't actually have it. But that could mean they go through treatments, they go through stuff that doesn't have to happen to them. If your recall, though, is low, you're actually predicting people that have cancer do not have cancer. And that's bad. So a low recall is also a bad number to deal with. And there's a lot of information out there on these numbers, but these are the numbers that you care about when trying to evaluate your model. Well, Brian, I'm happy with this model. So we're going to take this model and we're going to create a web service from it. Now what happens when we take this model to create a web service from it is that you can see it's moving some stuff around. It's actually taking the trained model, putting it in place, and it's done a couple of things such as add a web service input at the beginning. It's added web service output at the end. One of the changes I'm going to make here is I'm going to change where my web service inputs to down to here. That way we've already done a select columns and data set, so I only have to enter those 6 columns versus entering name and ticket ID, things like that. So with our web service in place, we got to save it, and we have to run it, just to make sure we didn't break anything. And then once we save it and run it, and it works, we're going to just push this sucker out as an actual web service. Because Brian's smart. He's a programmer. He could consume a web service. I'm glad you're here, Brian. So, almost done. So it compiled and it worked. So I can just deploy this off as a web service. And I can give it a name. So we'll say, does Brian survive 2017-10-13? Sure, that's a good name. And we'll choose our plan, which was this one, and we'll deploy it. So what I like about this is it takes a lot of the effort that I would otherwise have to go to put this out where people can consume it. I don't have to go to a lot of, okay, let me go figure out or go find somebody to help me push this out. Instead, it's going to put a web service out there. It's going to and then it's going to show me the different endpoints, and I'm going to get a lot of information on how to actually access this and test it, which is the next point, right? We've put this web service out there, but before I let Brian look at it, I better test it, because I need to know how it's going to work. So I can easily click just test web service. And here's the inputs. So we're going to say, we'll try survived. We don't want to give it away yet about Brian. So we'll try survived. We'll say first class, a female who was 27 with one sibling and one parent. And you can see that there's a 100% chance that this person's going to survive. So if you were female 27 with one parent and one child, you survived. I don't think that's Brian. So that's one way we could test this or work with this. I could give this to Brian and say, go run this. Or let's say we had lots of data that we wanted to test with and work with. Well, I can go to consume, and I can actually download an Excel spreadsheet that's connected up to my machine learning. So if we open that up, and I will enable editing. So here we are connected to my machine learning. We can see the schema. This is what it's expecting as an input. So let's go back over to our test data, and let's grab some data here. And we'll paste it in. So what I can do is say, okay, we're going to select all this data. I want to send all this data to my web service. So we're going to select that range of data, and my data does have headers. And I'm going to tell it to put the output starting at A12 and predict. You'll notice my columns don't match what my web service is expecting. Okay, that makes sense because we don't need name. We don't need passenger ID. So that looks better. So let's try it again. And here's my output. So you can see for the most part it scored these almost exactly the same as what was expected. So this is another way that Brian could use the machine learning model that I generated. I give him a Excel spreadsheet. He can put data in it. You can also do this to batch large pieces of data at the same time if you want to. But, Brian may use this. He might not. Well, Brian's a developer, right? So I'll give Brian some code. So down here, Azure Machine Learning gives me C#, Python, and R code that I can use to be able to test my web service. So we could come over here and say, hey, Python. How many people in here like Python? That guy likes Python. Okay. So we can come in here and copy this Python code over. We can go back to our experiment here and create a new notebook. So this is going to create a Jupyter notebook where we can take that Python code, copy it into here, and all this code does is, we create basically a class and pass that in. but I need my API, which of course I have. Back up here is my API, or my key. So we'll come back over here to our Python code and paste that key in, run this. Oh, so let's modify these. So we're going to say survive. We're going to say this is a female, age 27. And if we run this, you can see we get our results back. And here's our scored label of 1 and our scored probability of 1. And this is also an example of using the Jupyter notebooks that I was talking to you about. I've got another example I'll show you in a moment. So we've got all these different ways that we could consume our web service. However, Brian's been busy working on his talks for TechDays. So he needs a website, right? So we're all developers. We could build a website. But why build a website when you can have Azure take care of that for you? So I'm going to come out here, and you'll notice that one of my options that I have is an Azure Machine Learning Request Response Service web app. So this is a web app that I can point to my web service. So let's create this real quick, and we'll call this Does Brian Survive? Oh, that name's already there. So we'll call it, like any good people do, Does Brian Survive 2? And you'll notice it's just a website, right? So it's going to be doesbriansurvive2.azurewebsite.com, or better yet, instead of that, we'll call it Can Brian Survive? There we go. So we'll all be able to hit this website if we want to. We'll create a new resource group, that's fine, and we'll click Create. Now this is going to take a couple of minutes to build. So while this is building, I'm going to go ahead and we're going to come back and modify our experiment. Now we're not modifying the web service. We're modifying the experiment in the workspace to go ahead and add a second model. Just in case this first model doesn't work like we want it to, we'll go ahead and add a second model. So we're going to say, come into our model here. And let's see, we're going to use two-class logician regrestics. So I can't type. Two-class logician regrestics test. So we add another train model. Train model. Link these up. Then we score it. And by scoring it, we link these up. We need to tell our model that we're training what we want to train for, which is the survived column. And then we can put this into the same evaluate model, and we can compare the two. So we're going to save this. And we're going to set this running. And while this is running, we'll come back over to our web service. And of course, our web service is still deploying. So, Brian, you know any good jokes? No, just kidding. If you came to our talk yesterday, you know the answer to that. If you didn't, it'll be posted at some point. So, you can see our model is running through. There we go. Our website is deployed. So let's go check this out. So if I open up canbriansurvive.azurewebsites.net, there's some configuration that I have to do first. I've got to give it the request response, so we'll copy that. I have to give it the API key, so we'll copy that. So we're telling it what web service to use. And now I can go in and I can make things a little prettier if I want to. So for example, I could call this input, does Brian survive? And I could say 1 equals yes, 0 equals no. So I could add aliases and I could add descriptions just to make it a little prettier for the end user to use. And I can save my changes. Okay, moment of truth. So does Brian survive? I'm sure Brian thinks he survives. He's traveling by himself. He's in first class. He's traveling by himself. He is male. And what age would you like me to try you with, Brian? 40. Brian's 40. So we submit this. And unfortunately, Brian, when you were 40, you only have a 21% chance of surviving. So we'll try something close but not necessarily accurate. And but if you're 45, you just barely survive. So you see, depending on when you traveled on the Titanic, you may or may not have made it. Let's try 47. And with 47, again, no chance, 12.5%. Okay, I know Brian's not going to like this, so maybe I can find a model that gives him a better chance. So let's go back to our experiment. And our experiment is finished running. And if we look at evaluation, then we can see that this is the blue line is the original model. The red line is the new model. And if we look at the numbers around those, the red has a slightly higher area under the curve, but it also has a slightly lower precision and accuracy. But you know what? I like Brian. So we're going to try this other model. So what I'm going to do is select the second model that we just created, and I'm going to say, update my predictive experiment. Let's try that again. Update my predictive experiment. Now this is going to update the predictive experiment that is in my machine learning tool here. So now what I need to do is save this. I need to run it, and then I can redeploy. And it's going to realize that, oh, we have a web service tied to this, so let me just redeploy to that web service. And then we'll be able to test our web service with the new model to see how Brian does. So we'll give this just a moment to run. All right, so that finished. So now we can deploy. And it's going to come back and it's going to say, hey, you want me to update? Yes, I do want you to update. So with our web service updated, we can now go back to that same website, canbriansurvive.azurewebsites.net. I'll leave it up all week. And we'll be able to see whether Brian actually makes it out. So let it finish loading here just to make sure we're good. So we'll come back. We'll reload the site just to make me feel good. And we're going to assume that Brian does survive. He again is traveling by himself in first class. He is indeed male. And let's see, we initially said if you were 40, did you make it? Well, you got a better percentage chance this time when you were 40, but you still didn't quite make it. If we change it over to 45, which you barely survived that last time, this time you don't. All right, and if we go with 47, remember 47, he had a 12% chance. We're back to a 38% chance now. So Brian's still got a better chance of survival, but he doesn't. So the moral of the talk is Brian probably didn't make it off the Titanic. Sorry about that. Now, so what I've shown you so far is using a lot of the built-in stuff that you get with machine learning in Azure to be able to build out these kind of models. And there's a lot of examples out there that you can use. And in fact, if you go to, let's see, let me find my notes here. If you go to gallery.cortanaintelligence.com, this is just a site chocked full of different machine learning examples. So one of the examples that's out there is flight data, where people are using flight data to predict different things, like is a flight going to be late? based off of, say, weather, based off of, multiple different factors. Now, what I like about this is these people have already built out most of these experiments. They give you a description of what they're doing, and you can click this button, and it will automatically open up in your Azure Machine Learning Studio. So then you could take that and build off of it. So that's what I've actually done already. So let me come over here and switch. So I'm going to switch back to South Central US, so it may be a little bit slow. But I chose that flight testing, trying to determine if a flight's going to be late or not. And I've added to this a little bit. So what I've added to this is, it doesn't show very well, but we're doing a two-class logistic regression. But notice that after the score model, I'm not doing an evaluate model. I'm instead running some Python script. I've decided to do my own scoring, build my own scoring model. And the Python script, essentially what the Python script does is it creates that graph for us, and then calculates some of those statistical values that we wanted. And if I visualize this, then the first visualization shows me all those different numbers, true positive, true negative, things like that I was using. And the other visualization shows me the actual graph. So I can take Python scripts, R scripts, and intersperse those into the logic of the model that I'm building. So I don't necessarily have to say, okay, well, I've been doing machine learning a while, and I've been using Python and R and whatnot, and throw that away. You don't have to do that. Now, one of the other things you might want to do when you're starting to build out these machine learning models and whatnot is you may want to do some just quick data manipulation or some quick, trying to look at the data in another way to be able to use it. So what I've done is I have taken my data once I've finished manipulating it, and I've converted it into CSV data. And then what I did is actually right-click on that and open it in a Jupyter notebook. And here's the Jupyter notebook that I opened it in. And this is why I'm really starting to like these Jupyter notebooks. Because what this is doing is saying, okay, from your workspace, go grab that CSV file, and when I run this, it shows me all the data that it grabbed. Well, I want to start correlating some of these different pieces of data to see if I can figure out a way to see if one piece of data might be impacting another. Well, one of the things I know I don't need is carrier, because carrier doesn't tell me anything. So as my next step in my Jupyter notebook, I just created a new frame where I dropped carrier, and then I ran it, and you can see that here's where I pulled out that data. And then I had some code that basically creates a heat graph for me to show me the data and the relation of the data to some of the other data. And of course, we're going to get red all the way down, 100% all the way down as a diagonal as each row matches each column. That makes sense. But one of the things I noticed that we noticed that is interesting here is this arrival delay time is the one that we really care about. And right next to it, we've got departure delay is also very related, which makes sense. Arrival delay, departure delay. If you arrive late, maybe you departed late. That's why you arrived late. But the point of this is a quick way, using some Python, that I took the data that was already in my machine model and therefore was able to look at it, and now I can go, okay, well, what happens if I take departure delay out of my predictive model? Does it make things worse? Does it make things better? So the point is, you're going to make use of both the machine learning workspace as well as making use of your Python, your R, whatever, to be able to manipulate your data and be able to build this stuff out. So machine learning is awesome. Go try it. I like it. I think it's really cool. Enjoy the rest of your day here, and I really appreciate you attending my talk. And we nailed it right at 45 minutes. So thank you very much.